All right, everyone, let's talk about manipulating images. So this is a little bit of review, but I want to make sure we're in the proper headspace here to appreciate images. So image files work on a pixel grid. There are some counterexamples to this, but the basic image files that we use in P5.js are what we call bitmap images, meaning that they are simply which color goes into the grid spaces. So each one of these grid spaces, each pixel, as we call it, holds an RBGA value. And we've talked about how that A value is transparency. So when you picked your ship to use in Lab 7, we encourage you to use a PNG that had a transparent background. That way, it was treated as an alpha channel that was fully transparent, so you could see right through it. So you didn't have that white square around your ship. And we had a hard time doing that. Like, it was actually kind of hard to find those because you would go and you would search for PNG transparent images, and then you would turn on Creative Commons, but they'd still send you to pay sites, unfortunately, often. And those pay sites, they have that grid in the background that makes it look like it's transparent, but when you save the image, it's actually a JPEG with no transparency. It was very frustrating. So this is why we use Photoshop and Illustrator and things like that to make sure we have a true transparency channel or alpha channel in our images, so that when they are interpreted or output or exported as something like a PNG, you actually get that transparent effect when you use them in things like open processing in P5. All right, so the image class. Oops, looks like I had a typo. Not PImage, just image in this case. We talked about this in the lab quite robustly, but it is an object, a class that when you instantiate objects from it or make an object from the class, they hold the width and height of the image, they hold the pixels of the image, and they give you access to a bunch of properties and methods for you to manipulate images, like filter. So loading the image is as simple as getting a file name that is either a URL or is a raw file name that leads to that corresponds to an image file uploaded to your project. And then load image returns an image object. We also learned that there were two other parameters to load image. One was a success callback, one was a failure callback. So after the image is loaded and completed, it would call whatever function name you gave it as a second parameter and call that function and pass the image that it just created as the parameter. That's how we got scanlines to work, for those of you who delved that far. And the last parameter is like somehow if the image failed to load, you lost internet, if the image got corrupted on the way over, what have you, then you could it would call the failure function, the failure callback, and you could handle it. You could maybe try again, give a message saying, hey, something broke, restart, that sort of thing. And that is paired. So load image is paired with another function called image, which is very similar to rect, circle, triangle, where you have to position. So give it a position and give it its height and width. It's sort of like size of its presence in the world. The difference between image and rect and circle and all those is that it has a first parameter, which is the image object that you want to draw. So the generic form at the bottom looks like this: the image object, X and Y position, and the width and height of the output image. The width and height of, I guess, the area you put onto the canvas. The actual width and height of the image can be independent from that. Like we saw when we squished the nebula to be half of the screen width. But you can also create a blank image that you can draw in however you like. That's kind of neat. Create image, width, height, RBG. You could also set that image to be the background by passing the image to the background function. Now, I think you can I actually haven't personally tested this in P5. It was very prominent in processing. I would be surprised if it didn't work the same, but I will double check for you. Rendering will affect the state of the image, so you can translate and rotate your transform before you place an image. just like with rectangles, circles, all the other primitives we've been drawing, they respect translations and rotations and push and pop. Same holds true for images. Let's look at a quick example. Basic image manip. So you'll see that we do have some examples. There is an images category now in the class, so if you want to follow along, they are there. So here we are with this example, basic image. This is the image. Super cute, right? Maybe some of you get to meet Yogi someday. This is my cat. He is in a cabinet when we last moved, inspecting everything and being super cute while doing so. So that is the image we're using, yogi.png. So we have a count image, we have a translation X. So what we're doing is we're drawing. We didn't show this off in the example, but you can set the general tint of the next thing to be drawn. This works like fill and stroke, where it sets state and the things drawn after it will respect that. So this is why it looks a little, so we'll run it. So Yogi normally looks like this with this coloring. And now Yogi looks yellow. Right? Maybe Yogi's having a bad day. Maybe he's a little angry. And he's red. So you can change tints of images. This is kind of handy. You can change tints over time. So instead, we could turn the green component to be frame count. And you'll see that it changes over time. Yogi's a good boy. Now, just to bring home the fact that, let's just change this back to 100 again. The fact that you can use translate and rotate, we're going to scale and translate the image and just make a little animation from it. Who scared him? He's going away now. Bye, Yogi. Okay. So that's just to confirm that images, they're basically just like rects and ellipses. We have mostly the same affordances with them, but it can go a little deeper. So that was basic image manip. So talking about tint. So tint can sort of like alter the chromatic properties of an image before it's displayed. You can change its intensity, which basically, changes, can bias images more towards white or more towards black. So you can adjust the brightness. You can also adjust transparency with it as well. With intensity plus alpha, you can make something darker and more transparent. You can make something lighter and more opaque. So it adjusts the brightness of each color channel. You can also change individual colors like we did with how we used tint and made it a little more yellow and a little more red. And you can use it in the form where it takes R, B, G, and A. So you can do all of them at the same time. So there's a bit of flexibility with tint. It's kind of a handy function. You want a character, like in your game, that gets more red as they take damage. Tint's a perfect way to do it. Even with pixel art. So here's something that you could do. You can map, to play with this, you could map the tint values to mouse movement. And then you could even map two color values to the mouse movement as well. You could have like red and blue mapped to mouse X and mouse Y, and could change it from not purple to purple by dragging it around. This is just to say we have a lot of flexibility. That's because we're in like this programming language in this environment that is pretty composable. You can use your mouse movements for anywhere that takes a number, right? You can use mouse coordinates. Same with incoming amplitude of sound waves coming in from your microphone if you use the sound engine. You can use that to change colors on the screen. Lots of stuff you can do. All right, so this is probably where your understanding of the lab sort of hit a wall. A lot of you understood what draw stars were, and you could handle the fact that we're using objects and arrays together to draw stars that moved from the right to the left, fell off the screen, and popped back to the right. That seemed to be fairly comfortable with a lot of people. But when we looked at scan lines, those were much less comfortable. But basically what those scanline functions were doing is they were making the old movie scanlines. If you've seen the Fallout series on Amazon Prime, you'll see that their old monitors they had what looked a little funky, a little fuzzy that we don't see on our TVs. And those were prominently scan lines. If you watch videos of old Nintendo games, Atari games, things with the big old deep monitors, the big old deep TVs, those were cathode ray tube TVs, which we'll talk about next class. So scan lines were sort of like emulating the effect of those. And basically, every third pixel by default, every third row, we would alter the transparency of that row to be more transparent. And we would do that until we ran out of spaces in the image. That's all that scan lines did. We just added every so many rows, we changed all the alpha values to be lower by an intensity parameter. And we did it in two ways. So if you look at the first one, maybe I'll just open it up so we can have a quick reference. That's assignment 4. There's lab 6, lab 7. Way. So scan lines. We did this in two ways. The first way is we used get to get an XY location pixel out of the pixel image. And when we got it, we got all of its values. We subtracted all the values by an intensity value, and then we set that new darkened color RBG, I guess we use darkened algorithm instead of transparency. What was I thinking? We missed with intensity, not alpha. My brain some days. So it's been a long day. So we take those new lowered intensity RGB values and we set them to be in that XY location. So we replaced that value with a new one, that pixel with a new value with lower intensity. And then after we've changed all those, we call update pixels. So first, you load pixels, which makes that pixel array available to use. We did a bunch of manipulating of it here in the middle with the intensity values. And then we called image.update pixels, which locks in all those values. Transfers that pixel array that we manipulated, loads it back in to like its internal encoding so you can then use it and display on the screen. Now, apply scan lines is different. So set actually does a lot of like internal management, a lot of number crunching for you. And it's slow. Get and set are very slow operations. And we're doing a bunch of them. So there's one way around this. You can start manipulating the pixel values directly in the arrays. So like we talked about, and we'll go over this, each 4 values in the array is representing a red, green, blue alpha value. So the first pixel, the top left, 0, 0 pixel, like pixel 1, 1, the top left, is the first 4 values of the array. And so by manipulating this array directly and doing some very fast array operations, we can reduce it. It's easily 10 times faster than the get set method. And you can see how this works. So if we went here, there's scan line. Okay, we didn't call it here. So if we did apply scan lines here and we ran it, it's going to apply the scan lines every frame. We'll see how slow it is. Oh, did I mess something up? Oh, yeah, thank you. No, apply scan lines. Yeah, it takes the image. Thank you. Space. That is my bad. All right, and you can see it's actually super slow. Look how slow the stars are moving. That's the time it takes to do the scan lines between each frame. Right, that's pretty slow, right? That's like 1/1000. Like it's about a frame a second, 1 FPS. Now, if we instead use the second version of the function that makes pixels directly, so in this, it's called apply scan lines fast, you'll see it's significantly better. Right, so that's just by changing, using a different type of method for changing intensity, you can see there's a direct and very like prominent performance difference. This is playable. The other one was not. Okay. So we've looked at a little overview of how to manipulate pixels in an image and load them in, manipulate them, and lock them down with update pixels. So looking at this, there's just a little formula for you to use to turn like X and Y values into array indices. So you can have a little formula, like if you wanted to do the scanline operator again and you wanted to write it yourself, here's a little way where you can find all the alpha values. So to basically get a location in the array that you want to manipulate, the basics is number of rows times width times the number of columns. If you were just in a 2D grid, that would give you the right array, the right index. So that would be like saying 0, 1, 2, 3. And that works for two-dimensional arrays that are sort of like smushed into one dimension. And that's pretty common. You'll find that in other places in P5. So I'm mentioning it here as the first step. But we're in this situation where every 4 array indices is 1 pixel. So we have multiplied by 4 here. So if you wanted to get the location of XY's, the index in the pixel array for the XY pixel location's red value, you could use the first one of those 4 formulas. And same with green, blue, and alpha. Right, so if you want to do some pixel manipulation, here's a real like handy little formula for you to find those values. And so here's what it looks like, sort of stretched out. The first pixels RGB values are index 0, 1, 2, and 3, then 4, 5, 6, and 7, then 8, 9, 10, 11, so on and so forth. Does that make sense? Is everybody, is that too much math? It's hard to tell sometimes with this class, like what's syncing and what's not. It's syncing. I'm sure of it. I'm sure of it. So double buffer displays. We're going to cover this more in depth tomorrow, but I wanted to give a little preview. So double buffering is really an interesting thing. So basically it's you display an image. And while that image is displayed, you're working on the next frame in the background on a separate image that's not being displayed. And then when you're fully done with it, you swap them. And then you draw on the other one again for the next frame. And when it's done, you swap them. So you're never displaying like a partial or halfway done scene. You're always having a full frame. Now, does anyone know how you experience this in interactive things, particularly games? What this looks like when you don't do double buffering? Yeah. Screen tearing, exactly. So, and we'll have some screenshots and we'll show off this next time. But if you move, like if you're in a first-person shooter and you move really quickly to the left or the right, and you don't have like VSync turned on or double buffering turned on, what you'll get is part of the screen is rendered at one frame, and the other part of the screen is rendered at another frame, and so you have like this disjoint where the world like is schismed. So like if you had a tree right here, and you turned really quickly, you would have the tree as normal, and then it would be cut off partway through, and the top chunk of the tree would be like over here. Right? So the entire top portion where the frame wasn't completely rendered yet would be offset. Right? And so screen tearing's kind of a problem, particularly for lower resource things. It can be a problem in Pico 8, or Pico 8. That's another class, in P5. So we have this idea of double buffering, and this is really at the heart of making animations look smooth when you're rendering them on the fly. And we can do this with our tools. We can use load pixels to load the pixel of an image, manipulate it, and then we update. So this pixel thing that's built in, this is why we have load pixels, change it, and then lock it in. This lock-in process is a form of double buffering. So you'll never have like a partially manipulated image with this. You load it, manipulate all you care to, then lock it in. So that image, the thing that's locked in, will never be in a partial state. Okay. General manipulation workflow. So here what you're doing is you got an image file. No, this, I have some bugs here. Pretend this says let image here. This one I forgot to update from Java, darn it. So if you have your image file, let image, you can load the image, you change it, and then you can either load the image, use that image object from the image.jpg, or you can create a new blank image. Either way, you can still access this pixels. You can make its pixels property available to you by loading it. And we can manipulate pixels. So this is a general form. Like some versions of pixel manipulation in Pico 8 actually use this form where each location takes a color value. That's not the case for the image class. I just wanted to show you may find this in other areas when you are doing your final project, which is basically why this is here. Then you update the pixel values when you turn it, take it back to the image, and then you can display it. So a little formula for you. So initialize, transfer pixel values to pixel array, manipulate pixels, transfer pixel values back to the image from the array, and then you display. All right. I don't think we need to talk about this stuff right now. This will be better covered a little later. I think we're getting maybe a little lost in the sauce now, given like the number of eyeballs I'm seeing up front. Okay, so location image, I think we covered that well enough. So when you're working with two images, you can use them, you can compose them together. Like you have image A here. This can be a pixel array, this can be an image, this can be your background. So funny thing, if you just call load pixels without a dot in front of it, it'll actually load the pixels of the canvas. And then if you use just pixels without a dot there, you can manipulate the pixels on the canvas directly. And then when you update, if you just call update pixels without the dot in front of it as well, without an image file in front of it, it'll update the pixels in the background. It'll push whatever you change in that pixels array back to the background. And I'll give you some examples on this, and I'll send them out to you, and we'll talk about them. But you can work with two images. If you have image A and image B, you can put image B inside of image A. And they have different coordinate systems. They both have 0, 0s in their own respective coordinates, but the one inside of A will be offset by some X and Y value within it. So this is why that image call has so many parameters for sprite sheets and for image compositing. Right, their widths are not the same, their heights are not the same. Okay, I think that's enough for now. I want to give you some time to chat with each other about your projects. Are there any questions about image, pixel arrays? I mean, that was pretty fast. I'm going to give this to you so you have a reference. This will probably something you want to come back to if you're going to use it. This will, like images and using pixel values, was going to be like the core focus of assignment 5. So if you're interested in that, this will be slides you'll want to understand and look at it and sort of come to terms with. All right, questions about images? All right, there's actually one more demo I want to show you just real quick. So we have Yogi. Yogi's back. So this is a filter gadget, so you can play with the filters. So I can press T. Oops, let me put the focus on Yogi. Press T, and we use the threshold. Right, Yogi's now thresholded. We can press O to take the original image back, grayscale him, opaque him, that doesn't really show very well, invert him. So dramatic, right? Ah. We can posterize Yogi. We can blur him. We can erode him. This is a little sad because he's got his top right whisker goes away when you erode it. He loses a whisker. It's really, really sad. And we can dilate Yogi. And some of these take parameters. You can see posterize and blur. They take a value that goes along with them, which is the amount of blur, the amount of posterization you do, or the amount of reduction of color space that you do. This also reason I wanted to give this example to you is it's a way of like doing a bunch of interactions. Like it gives you a pattern for doing a bunch of keyboard-based like unit interactions that affect something. Right. So basically the draw function here. We have some, hey, are we showing the filter or not? If we are showing a filter, we apply it. There are a few edge cases here. If the filter is posterized or blur, we want to make sure we use second parameter as well to give it a value. But at the heart of it is this big if-else statement, which handles all the key presses. So if we press O, that's the original image. We turn all the filters off. And if it's T, we set the current filter to the threshold, right? So each one of these key values corresponds to a threshold that we then apply, right? And then here's a convolution. I wrote this for last class and thought I'd include it here. We're going to talk about convolutions later. They're a little more mathy, but they're really important for understanding how things like Photoshop and higher-end pixel manipulation works. Okay. That'll be enough for the recording. Bye, Internet.